Hello everyone, welcome to another video. So today we will learn about linear regression. Linear regression is a supervised machine learning problem. Here mainly we will have two variables. One will be our independent variable and second will be our dependent variable. Here I will call independent variable as input because we are going to use it as input, and the dependent variable will be our output or the value that we are trying to predict. So the relationship between these two independent and dependent variable is linear, meaning that whenever I make any increment in the independent variable or my input data, the output data or the dependent variable will also increase. And if I make any decrement in my input data, the output data will also have a decrement. So this is the linear relationship. Now, here in linear regression, what we want to predict is that how does my y changes when x changes. So x is our input and y is our output. So what we want to find is that how does my y, which is my output, changes when x changes, meaning that whenever input changes. So this is the intuition behind linear regression. So to understand how linear regression works, let's have this example. So here I have a data set where I have two variables. One is x, which is my number of hours a student studied, and my y is the marks that the student obtained. So what I will do, I will plot all these numbers first like this. So here at x-axis I have feature which is our number of hours a student studied, and on y is the value of the marks that each student got. So here is we plot the data. After that, the intuition is that we want to find a straight line that can describe all the data that we have plotted here. So if we look at it, there can be many straight lines, like maybe this one or this one or this one or this one. Any straight line can be used, but we want to find a line that describes our data in the best way. Suppose that line is something like this. So this will be the line that we want to find. We will call this best fit line. As we all know the equation for a straight line, which is y is equal to mx plus c, here we will call our straight line, this best fit line, as y is equal to wx plus b. Here m we have replaced with w and c is replaced by b. And here x is our number of hours a student studied, and our y is the numbers that he got. Now here we will call this y as y hat. So what we are trying to do is that already we have the value of our x feature. We have the data set where we have all the x values. So now we want to find the set of w and b, which is our learnable parameter. So we want to find a w and b which will give us this best fit line, and based on that we will predict another variable which will be our y hat. So this y hat will be the prediction by the model. So y hat is our prediction by model and wb are our learnable parameters. So these w and b will give us best fit line, and we will predict a y hat which will be as close as this y value we have. So we will have either here another y hat, and we will get all the y hat values based on the w and b, and we already have the x value. So based on that we will get the y hat, and this y hat will be very close to our true value, which is y. If we look at the straight line, the best fit line that we have got, the w will be the slope of this line and rb will be the intercept. Now the question comes is that how do we find the best w and b that will give us the best fit line? So once we have that w and b, we will have our y hat calculated based on that, and that y hat will be very close to our true y value. So basically we will be mimicking the true output value using our selected w and b. But the question is that how do we get this W and B, which is our learnable parameter? So we will learn that step by step. So training is the process of finding that best fit line. So it is a repeating cycle that we follow until we find the best fit line for our data. So the first step for that is that initialize the W and B with random values and then calculate the Y hat. So we start the process where we initialize W and B randomly and then we calculate our Y hat. So Y hat is nothing but Wx plus B. So here, suppose if I say W is equal to 1 and B is equal to 0. So this is the random initialization I have used. So already we have here X data. If you remember, we had this data where we had all the X and Y value. We will use all these values here in X and we will get Y hat. So we will have all the Y hat values. So in this first step, we are not looking at the actual value, which is the true output. We are only using the input data, and based on that, we are calculating our Y hat based on the initialization we did of W and B. So after the first step, we have the second step, which is cost function. So cost function is nothing but calculating the errors, as we have already got our prediction, which is Y hat for our chosen W and B. We have our prediction and we also have our actual data. So based on that, we want to find what is the error between these two. So for that we use cost function. For each ML algorithm we have a specific cost function. For linear regression we have cost function which is mean squared error. So its equation is like 1 upon n summation of I is equal to 1 to n yi minus yi hat whole square. So you see here the square is the square factor and then we are taking the average of all the data points we have from I to n. Here we have 1, 2, 3, 4, 5, 6, 6. So here our n will be 6. So we will have 6 error between yi and y hat and then we will take its average. So that is how mean squared error. So to understand it better, let's try to visualize it. So here I have created a plot where on x-axis I have my x value, the input values, and on y-axis I have y and y hat. The y hat that we predicted and the y which is our true value. So here all the blue dots are the actual y value and the line that we got using our initialized w and b is this line. And here for the cost function what we are trying to do is that here I have my y hat, here the corresponding y hat. So all these white dots are my y hat that my model is predicted. So in mean squared error in cost function what we are basically doing is that we are trying to find the distance between these 2 points. So we take all these distance. Suppose this is d1, this is d2, this is my d3 and so on. So we take all the distance d1 plus d2 plus d3 and so on till our last point which is our d6 divided by 6 because here we have 6 examples. So we are taking all the distances and then taking average. So this is our cost function for linear regression. The intuition behind the cost function is that if cost is small, then we can say the W and B that we have selected for this iteration, which is giving us this line, has least errors. And when the cost is high, that means that the error is high. So here, based on cost value, we will change our W and B. So the goal of finding the cost is that find the W and B that gives least cost value, least error values. Now the third step is to find the gradient. So as we know, we have our x data with 6 data points that we are considering for understanding. We also have true output for that. And now with the help of the initialization that we did, our W and B, which we took as 0 and 1, with the help of these W and B, we got our Y hat, which is the prediction that model made using a line. Here I will have one cost value for each pair of W and B that I use. So I am here renaming it as J of W and B. So whenever I write J of WB, that will be my cost value for that respect pair of W and B. So if I try, let's say 5 set of W and B, then I will have 5 different cost values, 5 different J of W and B values. So if we plot these values in a graph, then it will look something like this. So here I will keep on X the W that we are trying, and on the Y axis I will keep the cost value. So this will be my J of W and B. So if you see here, this is a squared function. If we see here, this is the cost function that we have. So it's a squared value. So that is why the curve of this will be a concave. So if we focus on the goal that we derived in the second step, which was that find the value of W and B such that they make the cost function as low as possible. So here in this graph, we are interested to find out this value, because here we can see the cost value is least. So we have to find what W got this least value. So we are interested to find this W value. But let's say with our random initialization, suppose we were somewhere here. So we have to find out that how do we move to this value. So at the first iteration, we will not have this entire picture that the W that I have selected, which is here, least amount of cost value is somewhere around here. So I have to increase my W to reach at this W. That knowledge we do not have. So that is why we calculate gradient. So what gradient gives the direction in which we have to move, where we will get the least cost value generating W and B. So here I'm only talking about W. The same way, we will also have to follow all the steps to find out the B as well. For simpler understanding, we will consider W only. Suppose I am here, my initialization I did. So from this point, in which direction I have to move to get the least cost function. So that is how gradient is going to help us. Should we move to the right direction or to the left direction? That we do not know, because we are not aware about all these other values. At this point, we are only here. We have to have a direction in which we have to move. So that information will come from the gradient calculation. So the direction will come from the sign of the calculated gradient. So if the sign is negative, then it means that we have to move to the right direction of the current W, meaning that increase the W. And if it is positive, then we have to move to the left direction or decrease the current W's value. To understand this concept of these signs and to get the equation of our gradient, let's have a look at it. So we will start from our cost function, which was on n summation I equal to 1 to n yi minus yi hat whole square. So if you remember, here we had earlier our equation which was wx plus b for y hat. So we will put that here. So our equation will become 1 upon n summation yi minus wxi plus b whole square. So now we are interested to minimize our cost function. So to minimize it, we will take partial derivative with respect to W. When we are trying to find W, we will take partial derivative with respect to W, and when we want to find the value of B, then we will do derivation with respect to B. So how my equation will become after that? Our equation will be, first of all, it will come 2 by n summation yi minus wxi plus b, and the square will be gone, and then into minus xi. So my final equation for gradient will be minus 2 by n summation yi, and again I will write wxi plus b as y hat into xi. So here you see the sign came. Why? Because we don't have any square here. We do not have that. In our cost function, that sign was there. Here, the sign was present. So this difference, the error will always be positive. So here we can never have a negative value as cost function. But here in gradient, we will have this negative value. So the next step is to use the update rule. So here what we have our cost value that we have calculated based on the W and B that we used. We also have calculated our gradient value. Now based on these two, we want to update the value of W and B in such a way that gives us least cost. So this will automatically give us our best fit line. So the update rule is something like this. So here we have to update our value of W. So we will say W new is equal to, we will use our old W, whatever W that gave us this cost value and our gradient. We will use that W old minus, here we have another new term which is alpha into our gradient. So here this alpha is our learning rate. What it is the size of steps, size of a step that we have to take in the direction of the W. So if we go back to our graph, here we were here at this point. So first of all, we calculated our gradient value. So that gradient will tell us we have to go to right or to left. But how much to go to right or how much to go to left, that value that we will get from our learning rate. So learning rate is nothing but a fixed static value. So you can consider it as this size of this step. So it says that how many steps to take in what direction. So how many steps is our learning rate and which direction is our gradient. And based on that, we update our old W and then we get our new W. If you consider here the graph, is our graph of W versus our cost function. So our initial W was here and we wanted to move from that point to here, where we get the least cost function. So here this equation will be used. How it will be used? Here we have the value of 1. So after that we will calculate our gradient. So gradient will say that we have to increase our W. So what it will do, and actually we have to move to the right direction. So if you look here, what we wrote is that when we have to move to right direction, we will get the negative sign of the gradient. So here my gradient will be negative. In this case, when we have to increase our w from 1 to this, we will get our gradient as negative. So what will happen? I have this negative gradient. So my W new will be W old minus alpha into negative gradient, right? So this negative and this negative will cause a plus of alpha into gradient. So this is what will be added to my W old. Whatever it gets added to my W will have an increment. So naturally we will move to right direction, and this alpha and gradient is taking how many steps. So alpha is one step, and into gradient will give us how many steps to get. Suppose it's a 1 or 1.5 step to take or 2 step to take, so that information will come from here, the gradient. That value will be added to our W. So we will have operations like coming from here to here, then coming from there to here, then coming from there to here, then here. And then eventually, after multiple updates of our W and B, we will reach at this point where we have found our W, ideal W or optimal W, that will give us our best fit line. So this is how it will work. Now let's say in the initialization step, suppose I initialized my W with this value. As we are doing random initialization, we can start from any point like this, or from here, or from here. Any point can happen. So suppose this is my starting point. So now from here to here I have to find my optimal W. So what will happen here? Here my gradient has to make sure that my W is moving in this direction. So what will happen? My gradient will say that whatever y hat I am predicting, that is less than my true y. In this case, my gradient will say that you have to decrease your W value. So what will happen? My gradient, first of all, my gradient will be positive. And once my gradient is positive, my W new will be W old minus alpha into positive gradient. So this will make reduction from my old W. So we will move into left direction. So based on that, we will take multiple steps, and then we will reach to our this value, which is our final W value. So to sum up our linear regression training steps, first was that we initialized our W and B, and based on that we found out our y hat, and after that we found the cost value, which is the mean squared error value, and based on that we got our gradient. And once we got our gradient, it gave us information that in which direction we have to move to find the best W and B, and based on that we update our W and B based on the update rule. So this is how most algorithm works. This was the most basic example. All the deep learning algorithm that you see, those also work on similar approach. So here you learned not only the linear regression, but you also learn how gradient descent work. So the entire process of calculating the cost value, and based on that getting the gradient value, and then updating the W and B, the same approach is used in gradient descent. So after this you might have a question that how do we know that what is the least value of our cost function? How do we know that this is the least cost value? So during training, what happens is that this was our diagram. So here this was our W that we were interested to find. And suppose I start from here. So here in each iteration I will have a new set of W, because in each cycle we are updating the value of W and B. So in each iteration I will have new values of W and B. So based on that I will take small steps to reach to my ideal double. So during these each iteration, the model will say what was the cost for each of these iterations. So suppose for first iteration, I got my cost as 0.5. In my second iteration, I got my cost as 0.4. So in the second iteration, it will say that for the second iteration, we got the least cost value. So in third direction, let's say I got 0.2. So this will get updated to 0.4 will get updated with 0.2. And then let's say in fourth iteration, I got 0.1, which is the least. So then again, 0.2 will be updated with 0.1. And then in fifth, suppose I get 0.2 again. Here I moved from this point to this point, again to this point. So model will say that now loss has started to increase, move back to this point. So even if I move here to 0.2, again my gradient descent algorithm is designed in such a way that it will again push me to this direction, to this point. So anyhow I will end up here only, and whatever is the least cost value calculated during our all the iteration, that will be used to get our best fit line, because whatever W and B gave us this least cost function, this will give me the best fit line. So at the end of this training process, we have got ourselves this best set of W and B, which can help us with our initial problem statement that we took, which was number of hours a student studies and marks obtained. So using this historical data, we have found our best set of W and B, which gives us this best fit line. And based on that, what we can do is that in future, we can give. So for any new X data, which is how many hours a student studied, based on those X hour, we can find out what will be the marks he will get. So we can give this X as input in our equation, which is Y is equal to WX plus B. We can put this value here. We already have our B, W and B, and based on that we can get the Y value, saying that if a student studies for X hours, he will get Y marks. So next is multiple variable linear regression or multivariate linear regression. So till now we had our y hat is equal to wxb, where we had only one x as input variable. But in multivariable linear regression, we have multiple variables. So our y hat will look something like w1 x1 plus w2 x2 plus w3 x3 and so on till w and xn. Let's try to understand with an example of a data set. So suppose I have a data set with many variables, where I have variables like x1, x2, x3 and x4 and x5. So I have 5 input variables, and with respect to these input x variables, I will have my y output, which is my true output. Now here I will call my input variable number as j. So I have j features or j number of input variables. And on the other hand, I will call my data points with I. So I have I data points, where this is my first data point, this is my second data point, third data point, fourth, and so on. And for my each input variable, x1, x2, x3, x4, x5, I will have its corresponding weight, which will be w1, w2, w3, w4, and w5. So here our cost function will be 1 upon n, sigma I is equal to 1 to n. So basically in cost function what we do, we calculate the difference between the true value, which is our y, and the predicted value, which is our y hat on average, right? On average. So here for each data point I have my y value, and same way I will also have my y hat value for each data point, whatever number of examples I have. So we want to take the differences between these two values, y minus y hat. So that is why we have here I, because we have I data points. So we will consider yi minus, which is our true value, and yi hat, which is our predicted value, and the square. So this is the cost function for multivariable linear regression. Next is gradient. So as we are dealing here with multiple input variables, then we'll have multiple weights to be found as well. So for each of the input variable, we'll have separate correlation for each weight. Equation will be del j by del w j. So here, as we have j different features, we will have to have j weights to be calculated, and we'll calculate those separately. So it will be equal to minus 2 by n summation of I is equal to 1 to n into yi minus yi hat. So this is the differentiated version of our cost value into xj. So here this j will be equal to the wj. So for first weight we will use x1 feature, for w2 we will use x2 feature. So for whatever jth weight we are trying to find, we will have to use that jth input feature. So this is the equation for grade. So next will be update rule. So for update rule, we have our equation, which is wj new is equal to wj old minus alpha into del j by del wj. So this last term is nothing but what we calculated earlier for gradient. So this is how we have our update rule for our multiple variable linear regression. So this way we can have our weights calculated for each of our input variable, and based on that we can find our y hat. So this was the equation for multivariable linear regression.